another maths video. In this video, we're going to be doing a past paper walkthrough of the first ever GCSE Maths paper for this specification. Now, this paper came out back in 2017. There are a couple of sample papers that Edexcel released, but this is the first paper sat by actual students. So without further ado, make sure to like and subscribe, and let's jump straight in. Now, starting off nice and simple with a scatter graph question. We're shown a scatter graph that shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. And we're asked to write the coordinates of the outlier. Now, what an outlier is, it's the point which doesn't match the rest of the pattern. So clearly this point here doesn't match the rest of the pattern. So we simply write down the coordinates of that. So it's the x coordinate first, so it's 10, 19. Then moving on, for all the other points we need to write down the type of correlation. Now, as you can see, as the number of hours of sunshine increases, so does the maximum temperature, which shows a positive correlation. And then we're asked to estimate the number of sunshine in a town where the temperature is 16.4 degrees. So what we do is we go along from 16.4, we draw a line of best fit, we go along from 16.4 and then down. And I got 12.8 with my line of best fit. However, they will accept anything between 12 and 13. And then we're asked, a weatherman says, temperatures are higher on days where there is more sunshine. Does the scatter graph support what the weatherman says? And if you go back to the scatter graph, you can clearly see it does. With higher numbers, with the days where there's a higher amount, with days where there's a higher temperature appearing when there are more hours of sunshine. Next on, moving up to question 2, we're asked to express 56 as the product of its prime factors. We simply do a prime factor tree, breaking it down into factors until we're only left with prime factors, and we get 2 cubed times 7. Then moving on to question 3, we're asked to work out 54.6 times 4.3. Now, because this is paper 1 and it's a non-calculator paper, you have to there's many ways to do this. My personal method is just making it so it's all integer numbers. So I have to times the 54.6 by 10 and I have to times 4.3 by 10. And then what I simply do is when I get to the end, do all the standard multiplication stuff that you would have learned in year 6. And then when I get to the end, I divide by 100. So it was originally here, move it 2 along, and I get the final answer of 243.76. I'm not going to cover how to do long multiplication. That is a skill that you should 100% know if you're doing a higher tier paper, which this is. And then the area of the square is the area of square ABCD is 10 centimeters squared. Show that x squared plus 6x equals 1. Now what you can do is that square is just the side length squared. So 3 plus x times 3 plus x. So you simply set that up as an equation. Expand the brackets, so 9 plus 3x plus 3x plus x squared. So you get 10 equals 9 plus 6x plus x squared. Then you simply minus 9 from both sides to get x squared plus 6x equals 1. And then moving on to question 5. This rectangular frame is made from 5 pieces of metal. And then we're simply shown the frame. The weight of the metal is 1.5 kilograms per meter. Work out the total weight. Now, firstly, we need to work out the length of this diagonal bit. And to do that, we use Pythagoras' theorem. So 12 squared plus 5 squared equals a squared. So 25 plus 144 equals 169. A squared equals 169. So you just need to know the square root of 169, which you should hopefully know is 13. So then you simply take it across because it's a rectangle, the top length is going to be the same as the bottom and the left is going to be the same as the right. You simply add those all together plus the 13. So 12 plus 12 plus 5 plus 5 plus 13 to get 47 meters of metal. And then you simply times that by 1.5 to get the weight, to get the mass. Weight is not the same as mass. This maths paper is wrong. That's meant to be the mass of the metal. Shame on this maths paper. Yeah, and it's 70.5 kilograms. Weight is a force, and you need a gravitational constant for that. Shame on Edexcel. And then we're given for question 6, we're given two line equations, and we're asked to show that they are parallel. And how we simply do this is we take the second one, and we put it in the form of the third one. So we add 9x minus 5 to both sides, and we get 3y equals 9x minus 5. And then we simply divide both sides by 3. So we get y equals 3x minus 5 over 3. And then both the lines have the same gradient and are therefore parallel. Okay, now moving on to question 7. There are 10 boys and 20 girls in the class. The class has a test. The mean mark for all the class is 60, and the mean mark for the girls is 54. Work out the mean mark for the boys. So firstly, we have to work out the total mark achieved by everything, and we do that by timesing the total amount of people by the mean mark. So we times 30 by 60 to get 1,800. And then we work out the total mark for the girls, and we do 54 times 20 to get 1,080. And then we do the mean mark for everyone minus the mean mark of the total mark for everyone minus the total mark of the girls to get the total mark for the boys. And then we simply, to work out the mean mark of the boys, we do the total mark of the boys, which is 720, divided by 10 to get 72. It's a fairly simple question. And then we're asked to write 7.97 times 10 to the minus 6 as an ordinary number. Well, you simply move the decimal place 6 places to the left, so there should be 5 zeros before the 797, and there is 5 zeros, and it's just that simple. And then we're asked to work out the value of 2.52 times 10 to the power 5 divided by 4 times 10 to the power minus 3. We're asked to give our answer in standard form. Well, to do this, you look at the regular numbers and then the times 10 to the power of numbers. Looking at the regular numbers, you do 2.52 divided by 4 to get 0.63. And then 5 divided by 10 to the power minus 3. Indices laws, dividing you minus 5 minus 3 equals 8. So you'd think it would be 0.63 times 10 to the power 8. However, for standard form, the number needs to be between 1 and 10. Well, 1 greater than 1 and greater than or equal to 1 and less than 10. So it's actually 6.3 times 10 to the power of 7. And then for question 9, it's just a little bit of inverse percentages. Jules buys a washing machine, 20% VAT is added to the price of the washing machine, she then has to pay 600. So the original price of the washing machine is X times 1.2, the 20% VAT, is 600. So you simply rearrange for X, 600 divided by 1.2 equals 500 equals X, which is the price of the washing machine with no VAT added. And then for 10, we're asked to show that X plus 1, X plus 2, and X plus 3 can be written in the form ax cubed plus bx squared plus cx plus d. So what we simply do is we expand the first bracket to get x squared plus 2 plus 2x plus 1x plus 2. Add the 1 and the 2x to get x squared plus 3x plus 2. And then to expand with this bracket, we simply make the first half, which is this times by x, and then we make the second half, all of it times by 3. So you should end up with x cubed plus 3x squared plus 2x plus 3x squared plus 9x plus 6. And simplifying, you should get x cubed plus 6x plus 11x plus 6, which is showing that it's in the same form. And you may be wondering where a is. There's no number here. However, there's like an invisible 1 here, as you probably will know. Then we're asked to show the turning point, which is just you go along from the x point, so it's 1 minus 3, that's a fairly easy one. And then we're asked to write down the estimate of the roots, which is just a point where it crosses the x-axis, and you can read it off from the graph for the roots to be minus 0.75 and 2.75. And then for the next question, we're asked to find an estimate of f of 1.5. So what we need to do is we need to put 1.5 into it, go down to the graph and go along to work out what the y value would be, and that would be minus 2.8. And then we're just given a bit of indice rules that we have to know. 81 to the power of minus a half. It's simply anything to the power of a half is square rooted. So you deal with the square root first. So you get 9 to the power of minus 1. Minus 1 is simply the reciprocal. So then you get 1 over 9. And with part B, it's similar. You can either do the cube root first. I recommend doing the cube root first, because like doing the 1 over 3 part. So you get 4 over 5, because the cube root of 64 is 4. The cube root of 125 is 5. So you get 4 over 5 squared. Then simply that's 16 over 25. Then for 13, we're given a set of values and told that y is inversely proportional to the square of x. And we're asked to write an equation for y in terms of x. Well, inversely proportional means to the square of x means y equals k over x squared. And then we can simply sub numbers in. I chose 9 and 1 because that makes it easy. 9 equals k over 1 squared, k equals 9. And then you simply rewrite the equation with your value of k to get y equals 9 over x squared. And then we're asked to find the positive value of y, the positive value of x when y equals 16. So y equals 9 over x squared. However, x squared is also equal to 9 over y, just because you can swap them in that way if you do a bit of rearranging. So you get x squared equals 9 over 16, and then you get x equals positive or negative 3 over 4. However, you're asked to find a positive value, so you can just ignore the negative one. Okay, this is a nice question. It's a bit hard, a bit tricky to understand logically, but the maths is fairly simple. White shapes and black shapes are used in a game. Some of the shapes are circles, all of the other shapes are squares. The ratio of the number of white shapes to the number of black shapes is 3 to 7. The ratio of the number of white circles to the number of white squares is 4 to 5. The ratio of the number of black circles to the number of black squares is 2 to 5. Work out the fraction of all the shapes that are circles. And I sort of took this in like sort of a probability approach. Like what the probability would be if these were all put in a bag and like shuffled. So 4 over 5 of white shapes are circles, and 3 over 10 of the shapes are white. So, and 2 over 7 of black shapes are circles, and 7 over 10 of the shapes are black. So what you can do is you can simply do, if you were to draw out a probability tree, I didn't, I personally don't believe it's necessary for this question. You can multiply these to work out what fraction are black circles, and then you can multiply these to work out what fraction is white circles, and then you simply add them together. So it's 4 over 9 times 3 over 10 plus 2 over 7 times 7 over 10, which rearranges into 1 over 3. Then moving on to 15. A cone has a volume of 98 centimeters cubed. The radius of the cone is 5.13 centimeters, and we're asked to work out an estimate. Well, firstly, we need to estimate a value for pi. Pi is approximately 3, so if anything, the 1 over 3 and the pi just sort of cancel out and aren't necessary. And then the radius is 5.13. Well, that's approximately 5. So in the formula, it would be 25 because it's r squared, and the volume is approximately 100. So because the 1 over 3 and 3 cancel out, you get 25h equals 100, and you get h equals 4 centimeters. And we're told John uses a calculator to work out the height of the cone to 2 decimal places, and we're asked whether our estimate will be more or less than John's answer. And our estimate will be more than John's answer, as the numbers in the numerators go up, because like it would be 100. If you think about it, it would be 100 over 1 over 3 pi r squared h. No, just pi r squared because we're working out h. And the thing is, we round up the 100 and we round down both the r and therefore r squared and pi. So the numbers in the numerator go up and the numbers in the denominator go down. So our answer will be more than John's answer. N is an integer greater than 1. Prove algebraically that n squared minus 2 minus n minus 2 squared is always an even number. So we simply expand the brackets. N minus 2 squared is n squared minus 4n plus 4. So then we get n squared minus 2 minus, all in brackets, n squared minus 4n plus 4. Then we simply expand the minus in, so we get n squared minus 2 minus n squared plus 4n minus 4. The n squareds cancel out and you get 4n minus 6, which you could then divide 2 out of to get 2n minus 3, multiplied by 2. And therefore, it's always even, as it's a multiple of 2, and any multiple of 2 is even. I don't know why they told us it's greater than 1. This would also work if it's 1. Because it would be 2 times 1 minus 3, which would be minus 1, times 2. And minus 2 is still an even number. So I don't know why they've done that. If you do know, just leave it in the comments. I'm sure there's some reason, but minus 2 is still an even number. If it said even positive number, then that would make sense, but no, minus 2 is still an even number. 7 of the counters are green and 2 of the counters are blue. Ria takes 2 random counters out of the bag. Work out the probability. Ria takes 1 counter of each colour. You must show your working. Now what I just first did is I drew a probability tree of green and blue. So the starting probabilities are 7 over 9 and 2 over 9. And then for the green pathway, the probability of getting green again is 6 over 8, as there's 6 green counters remaining and 8 total counters remaining. And the probability of getting a blue counter is 2 over 8, because there's 2 blue and 8 remaining. Then for the blue pathway, it's 2 over 9 to begin with. Then for the second pull, it's 7 over 8 for green and 1 over 8 for blue. Just because once you take a counter out, you minus it from the total and you minus it from the amount of that colour remaining, because it's without replacement. And what the question's asking is it's the probability that it takes 1 counter of each colour. So there's 2 total pathways which I've sort of highlighted. So you need to get green and blue, or blue and green. And how you do that is, if it's and, you multiply, and it's or, you add. So it's 7 over 9 times 2 over 8 plus, because you can also do this pathway, 2 over 9 times 7 over 8. And like if you just simplify that, you should get the fraction of 28 over 72. Then moving on to question 18. A, B, C, D is a rhombus. The coordinates of A are 5, 11. The equation of the diagonal DB is y equals a half x plus 6. Find an equation of the diagonal AC. Well, because this is a rhombus, the two lines, if you draw the lines from D to B and A to C, they're perpendicular to each other. That's meant to be sort of an angled square. They're perpendicular to each other. So what you need to do is you need to find a line with the gradient that's negative with the reciprocal of a half that goes through 511. So I did that here. The gradient of AC is minus 2. Negative reciprocal of a half is minus 2. So it's y equals minus 2x plus c. You then sub 5 and 11 in. You then get y equals 11 equals minus 2 times 5 plus c. And then you get c equals 21. So then you just sub that back in, and your final equation of the diagonal AC is minus 2x plus 21. Then moving on to 19. This is a bit of a tricky question. OABC is a parallelogram. O to A and equals A, and O to C equals C. X is the midpoint of line AC. OCD is a straight line that OC to CD equals K to 1. Given that XD equals 3C minus a half A, find out the value of K. So firstly, AC equals minus A, because you're going A to C, because you're going back and then along, is minus A plus C. Then X to C is half of that, because it's the midpoint. So then C to D equals X to D minus X to C. And you have X to D. And you've just worked out that X to C is 0.5 A to C. So then you just sub all of that in. And you get 3C minus 0.5 A, which is X to D, minus 0.5 A plus 0.5 C, which is half of AC. And then the A's cancel out and you get 2.5 C. And if you get something that includes A in the answer, you've gone wrong, as OCD is a completely straight line, so it should only be in terms of C. And then the ratio of O to C to C to D is C to 2.5 C. So it's 0.4 to 1. So K equals 0.4. The issue with this question isn't that it's like particularly hard. It's not that it's particularly hard to do. It's just that you need to notice what maths you actually need to do. The actual maths itself isn't very hard. Okay, now moving on to question 20, in which we have to solve algebraically the simultaneous equations x squared plus y squared equals 25 and y minus 3x equals 13. Now, if you're used to solving simultaneous equations, especially quadratic simultaneous equations, your first thoughts are probably going to be substitution. And that was my first thought as well, as I added 3x to both sides of the bottom equation to get y equals 3x plus 13, and then subbed that into the top equation to get x squared plus 3x plus 13 all squared equals 25. I then expanded that to get x squared plus 9x squared plus 78x plus 169 equals 25. And then I just moved the 25 across and added the x squares together to get 10x squared equals 78x plus 144. Now, there's many ways you could solve this quadratic equation. I'm gonna be honest, we're in the last few questions now. This is only if you're doing like aiming for grade 8 or 9. So I decided not to include solving a quadratic equation, because if you're aiming for grade 8 or 9 and you can't solve a quadratic equation, you need to go do that before you actually attempt the grade 8 or 9 questions. So you solve the quadratic equation, you get x equals minus 3 and x equals minus 24 over 5. And then you work out the y values using the bottom equation for each case. So for x equals minus 3, y equals minus 3 times minus 3 equals 13. And then y equals 4, because 13 minus 9 equals 4. For x equals 24 over 5, y minus 24 over 5 times 3 equals 13. Just move that across, y equals minus 7 divided by 5. And you don't actually have to pair it up for this question, which is really weird, but I decided to pair it up. So when x equals minus 3, y equals 4. When x equals minus 24 over 5, y equals minus 7 over 5. I don't know why my PDF's having issues, but yeah, y equals minus 7 over 5. Oh, this is a tricky one. I personally don't like this question that much. ABCD is a quadrilateral. AB, which is this one, equals CD. Angle ABC equals angle BCD. Prove that AC equals BD. And what we have to do is we have to prove that the two triangles ABC and triangle BCD are congruent. We have to prove they're the same, because then the third side would also be the same. And what annoys me about this question is half the marks, this is a 4-mark question, 2 of the marks are just for repeating part of the question. So angle ABC equals angle BCD is 1 mark. Angle AB equals... No, angle AB equals CD, I don't know why it says F, it's meant to be a D, is another mark. And then you also get a mark for saying BC equals BC, which is a 3rd mark. So you get 3 marks just for doing common sense. And therefore, triangle BAC is equal to triangle BCD by proof of SAS, which is side angle side, and thus AC equals BD because it's the third side and they just must be the same. It's a very dumb question for 4 marks. Like, I think a better question would be put it earlier on in the paper and it just be to prove they're congruent. Because there's nothing in the question that tells you have to prove it's congruent. And like in these later questions, it's less about the maths actually being hard, and it's more so about you being able to decipher what they actually want you to do, which is quite, in my personal opinion, a bit annoying. And that's no more evident than in the last question, question 22. The diagram shows a hexagon ABCDEF. ABEF and CBED are congruent parallelograms where AB equals BC equals X. So I labelled them. P is the point on AF and Q such that BP, which is this, equals BQ, which is 10 centimeters, and they're each 10 centimeters. Given that angle ABC equals 30, prove that cos PBQ equals 1 minus 2 minus root 3 over 200x squared. Now, what you have to do here is, because it's a parallelogram, PQ is equal to AC. So what you have to do is you have to do cosine rule to get AC in terms of x and cos 30, and cos 30 equals root 3 over 2. That's something you have to remember. You have to do the cosine rule to get AC, and then you have to do the cosine rule again with AC equal to PQ to get this angle in terms of cos. So for the first thing, you just do cosine rule with AC squared equals x squared plus x squared minus 2 times x times cos 30. And then AC squared equals x squared 2 minus root 3. Where you just like put cos 30 in there and just simplify. And then you need to rearrange the cosine rule to get it in terms of angle and do it again with PQ. Now, if you are unsure how to rearrange cosine rule to get in terms of angle, you shouldn't be doing the last question. You can pick up other marks in earlier questions. If you can't do the last few questions and you're not aiming for a top grade, don't worry about it. Focus on the questions that are within your limits and try and get as many marks out of those as you can. There's no point wasting time on the last couple questions, getting like 2 marks on the last couple questions, when you could have been spending time on the earlier questions and getting like 5 marks from those. Only focus on the last few questions if you are consistently doing well at the rest of the paper. So, cos BPQ equals 10 squared plus 10 squared, as I said earlier, because PB plus BQ equals 10, minus PQ squared, which is equal to AC squared, which is equal to x squared 2 minus 3, over 2 times 10 times 10, just simple cosine rule stuff. Sub PQ in, and then you just do a bit of simplifying. You split up the fraction, 200 into 200 over 200, which is 1, and then minus 2 minus root 3 over 200 x squared, and that's it. Once again, the maths isn't that hard, it's just a bit difficult conceptually to work out what you need to do. Like, I know you may be hearing me explain, it's like, oh, that's obvious, but if you were to do this question without having me explaining it before, it's a bit tricky to understand conceptually what you need to do and why you need to do it. But yeah, this is one of the hardest questions in all of GCSE Maths, to be honest. But yeah, that's the end of the first ever GCSE Maths paper for this specification. And I'll see you next time. Make sure to like and subscribe.